Hello, my name is TC Brown and welcome to my presentation of oral versus nasal breathing during moderate to high intensity submaximal aerobic exercise. This research article was authored by Chase Lacombe and Company. The purpose of this research was to investigate which breathing tactic, nasal or oral, was the most efficient during increasing levels of submaximal aerobic exercise. As a summary of the research was conducted to figure out which was the best breathing tactic during moderate to intense aerobic exercise. The research aimed at healthy individuals with strict protocols to ensure the accuracy of the research. The research found that both breathing tactics are beneficial. However, oral breathing may be best during high-intensity aerobic exercise. These are a few of the articles that were very influential in the research process. Kamer and Bake, nose or mouth breathing. This article helped to reveal evidence that when at rest, a greater than 90% of healthy individuals use nasal cavity respiration. Hall, energetics of nose and mouth breathing, body size, body composition, and nose volume in young adult males and females. This study provided proof of benefits of oral breathing compared to nasal breathing during cycle exercise. Hoster, McLaren, Cox, Dahlman all authored a research of a triathlete adapts to breathing restricted to the nasal passage without loss in VO2 max or VV-VO2 max. This case study showed an experiment of a triathlete who adopted nasal passage breathing only, and after the triathlete adopted this, it showed an increase in VO2 max and time to exhaustion. Warren, Harefield, Seaton, Moore, and Smith, the relationship between nasal airway size and nasal oral breathing. This study, it gave the researchers essential information of individuals that might have an airway impairment that also could affect the present study. The problem the researchers were trying to find was what is the best breathing tactic? Which one would be the best one to use while increasing submaximal exercise intensity? The researchers shared two hypotheses during the research. One was nasal breathing would result in lower respiratory values at moderate and moderate to high exercise intensities and provide evidence for the first time in the literature that this response extends to work bouts greater than 60% VO2 max. The second hypothesis shared was when combined with the metabolic response in the form of ventilatory equivalencies, that nasal breathing would be beneficial during submaximal exercise. The materials used in this research were very many. Starting with the participants, there were 19 subjects, 9 male and 10 female. The male averaged at age of 25 years old with a height of 5'8" and a body mass of 185 pounds and a 16% body fat. Females averaged in age 24 years old, height of 5'5" and a mass of 146 pounds and a 27% body fat. Also used was the American College of Sports Medicine Health Questionnaire, a signed university-approved informed consent document. To do the body composition, they used a total in-body 720 body composition analyzer, a Borg's 6-20 rating for a perceived exertion scale, a treadmill, a Moxonus metabolic system, a V2 Hans Rudolph respiratory face mask, and a heart rate monitor. The study was accomplished by doing 3 separate occasions in an exercise physiology laboratory. The individuals had very strict protocols. They had to be well hydrated. They had to consume their last meal at least 2 hours prior to testing. They had to refrain from all caffeinated beverages for 2 hours prior to the test, and to refrain from alcoholic beverages for at least 6 hours prior to the test. One interesting fact that I found in this research was the participants also had to refrain from strenuous physical exercise during the day prior to testing. And the subjects also had to complete progressive tests to the point of volatile fatigue. In the first session, the subjects had to do the VO2 max test protocol. And this test was helped to determine the voluntary switching point from oral to nasal breathing. And to do this, the subjects had to breathe in the desired way until they were uncomfortable. Once they were uncomfortable, they had to raise their hand, and that is when the pulmonary ventilation was deemed the switching point at that moment. The VO2 max protocol consisted of a 3-minute treadmill walking warm-up at 3 miles an hour, and that increased to 5 miles an hour for 1 minute, and then increased by 1 mile per hour each successive minute thereafter until the test was done. In session 2 and 3, the participants completed a nasal and a oral breathing submaximal treadmill runs with intensities that increased from 50% to 65% to 80% of their VO2 max that was learned in session 1 for 4 minutes at each intensity. The researchers used athletic tape to secure the subject's mouth and used a swimming nose piece that was placed over the nostrils that was used prior to attaching the breathing mask. A regressive equation was used to determine the running speed that was attained in the previous VO2 max protocol. The submaximal protocol, it consisted of 12 minutes of running unless the participant was not able to complete the test. After 2, 3, and 4 minutes of each stage, RPE was collected. Collected from the researchers were different parameters, one being the respiratory rate, pulmonary ventilation, metabolic oxygen consumption, carbon dioxide production, respiratory exchange ratio, heart rate, ventilatory equivalents for oxygen and carbon dioxide. Now, these next few slides are slides that was from the research of charts and graphs used that showed the results. The first graph shows the respiratory rate. As you can see, the oral is in black and the nasal is in gray. Starting out at the 50% intensity, oral breathing had already began at about 34 breaths per minute, and it exceeded all the way to around 50 to 51 breaths per minute. That is extremely high compared to when nasal breathing was used. Starting at 50%, it was around 25 breaths per minute, and it only escalated up to around 38 breaths per minute at 80% of intensity. This next slide shows the ventilation. Ventilation, just as in the breaths per minute, was higher in oral than it was in nasal. And as the intensity grew, oral breathing increased at a significant scale, while nasal breathing scale did not increase as much as oral. Oxygen uptake, as you can see, it starts out at 50%, but as the 65%, what's very interesting is both oral and nasal breathing kind of went down. It did not follow the trajectory that was used from 50% to 65%, but it also increased, and the increases were similar. This table shows the mean and standard deviations of the different measures used, and you see the heart rate stayed relatively close to each other as compared to oral and nasal. The RER, it stayed relatively close also. One that did jump out was the VO2, and nasal was actually lower than oral, and the VCO2, nasal was lower than oral breathing. RPE stayed relatively around the same. Nasal was actually higher at different intensities. The chart on the left is the ventilatory equivalent for oxygen. As you can see, as the intensities increased, so does the oxygen increase. Nasal is really significantly lower than oral. As you can see, both in the 65%, they both have a dip also. In the right chart, it shows the equivalent for carbon dioxide. And you see the oral carbon dioxide chart, it does decrease from 50% to 65%, but it also increases when it goes from 65 to 80%. As the nasal drops completely and does not level off or go back up. This data was analyzed using a 2 × 2 × 3 ANVOA with a repeated measure on the last two variables test, and simple main effects analysis was used using the SPSS software. A 0.05 alpha level was used to determine significant results. The study found that the respiratory rate was significantly lower in nasal breathing than in oral breathing. And interestingly so, that the difference between the two tactics, the greatest difference in the two tactics, was at the highest intensity level. Pulmonary ventilation was significantly lower for all intensities when nasal breathing was used, and was increased as the intensity levels increased also. Nasal breathing, the oxygen uptake was 8 to 10% lower than oral at levels of all intensity. However, nasal breathing saw a 7 to 9% decrease of carbon dioxide production when compared to oral breathing. As all intensity levels increased, the difference between oral and nasal breathing increased in terms of ventilatory equivalent oxygen and carbon dioxide. The study did not find a significant difference in the two breathing tactics in terms of heart rate and respiratory exchange ratio, but according to the study, it did find that if individuals could use the nasal tactic throughout exercise, it would prove to be more respiratory efficient. Also, the respiratory rate was significantly lower compared from nasal to oral by nearly 17 breaths per minute. The researchers believe that oral breathing consumed more breaths because as carbon dioxide is breathed out, it causes a sensation to breathe more. It tricks our body that we need more oxygen as compared to nasal breathing. The researchers found that oral breathing proved to be most efficient mode of breathing during time of high intensity exercise. According to the research, the hypothesis stated in the study proved to be correct. Nasal breathing does provide better pulmonary ventilation and proved to produce lower respiratory rates during levels of low and moderate high intensity exercise. So they were right in their hypothesis. The researchers did share a need that further research needs to be done to continue the experiment. And one research question that was asked during the research was, how do you reach a steady state of oxygen supply? This proved to be a greatest contributing factor to the research. And the researchers believe that if they could provide a steady state of oxygen supply, that the research may change in different aspects. I would like to thank you for watching my article presentation. The article citation is below. If there is any need to look at the article was very interesting to me as a PE teacher and as a coach that tries to find the best way for my children, my students, and my athletes to breathe during times of intensity, during times of exercise, and during times of fun play to help support oxygen supply back into their bodies that makes them better students, better adults, and better players. Thank you for your time.